Well, it is with mixed emotions that I approach the last piece in this build. I have really enjoyed this, and I appreciate all the support and comments that I've been getting. Thank you all very much. Here it is, the crankshaft. I am going to start the same way I start with all the other castings. I'm going to take off all the ugly on this, and I'm going to check and see how straight it is this way and this way, to see if I can get away with a little bit different approach on this. Ultimately, yes, it will be finished between centers, but why rough it between centers when all that noise takes place? If this thing is straight and you can trust these diameters, well, grip it here, turn this, grip it here, turn that, and don't turn them to the finished diameter, of course. If this thing is bent or running out, you want to make sure that you leave sufficient material to clean it up between centers at the end. But I'm going to rough it out completely different than roughing it out between centers. And if I like the way it looks when I put it up between centers and it's all running true, I may just finish these guys up, held in a collet or such, and then finish these up between centers, because that's the only critical part about it. They do give you, well, this is critical diameter as well. They do give you a reference drawing in the PM Research kit for a fixture that you can make. And no, it doesn't suggest using hose clamps, but I guess if that's what makes it work, that's all that matters. So who knows, I might end up using them too, so I better not say anything too quick there. The one thing I did see, and everybody that's now rolling their eyes about that last hose clamp comment, was the other builder that did this mistakenly turned this diameter all the way to this face and then used bronze shims on either side of that particular feature. You know what? I sent her a message offline and said, nice job, and I really did like the creative recovery of that particular bronze shim. I think it's actually better than the cast iron elevations or the bosses that they have here. And if I can find a piece of bronze laying around, I may just copy that, because I really enjoyed that. And I think it was a great way to think on your feet and recover on the fly. All right, let's take this over to the sander. Let's take it over and hit it with a file, wave the magic wand, make all this ugly go away, and take another look. Hang around. To get a feel for how straight this casting is, I've got it sitting on a small surface plate on my bench, 1, 2, 3 blocks on it, and I'm looking at the gap between the casting and the top of the block. And that appears to be relatively straight. The only way to be sure is to go 90 degrees now. Look at it again. It does crown a little bit, but beware, that little gap right there, if you think that's only a small gap, if you were to hold that in a 3-jaw chuck or some other method supporting it by this end, that becomes a projected error, and when it lays flat on the blocks, the distance that this dips or rises, depending on that small gap, is like a gun sight. When you're looking 100 yards down the range, you may not move very much at the table, but you're 3 feet off center when the bullet strikes the paper. So beware small gaps like that. When you correct it all on one side of a fixture or one side of a part, you can really end up in a world of hurt on the other side. I might put this in a 3-jaw chuck and just dust it anyway, so I can trust the surfaces just to clean them up. This is a 511 diameter, cleans up at 374. So quickly in my head, that's about 12.7 millimeters currently, and cleans up at around 10. So I can take a dust cut on this and get a better feel for what I'm working with. Still going to do it between centers though, ultimately. Why not? Alright, off to the lathe. First step in my process is going to be to put a drill blank, a 1/2-inch drill blank, in my 3-jaw chuck. And I'm going to get that to run true. And use that as the standard setting. I'm not going to adjust anything. I am going to turn the journals one at a time, and regardless of what happens to the center of the part, the end that's trapped between centers will remain linear and can be center drilled in a step like this. Should you choose to approach this part this way, rotate the crank in the chuck and turn the machine on until you get this end of the part to run as true as you possibly can, or true to your liking. I know that I have a considerable amount of material coming off of here, so a little run out is acceptable. But I've got it pretty close. You can see the end. I sanded the end off because it's going to be very hard to machine this off, and the sanded surface is going to be fine. There's nothing that's going to reference that. Just make sure that your center drill is not influenced by any tilt you may have in that surface. I may try to face it off as set right now, but because of the extension, I just have to imagine it's not going to end well. It may chatter a little bit. So I'm going to try to center drill that first. Let's take a look at how clean this thing runs. It runs rather well, I'm surprised. Not bad. Does call for a number 2 center drill. Just for aesthetics, I think I'll go with the number 2. Nice and easy. Until you have a good footprint on the end, the drill's going to want to wiggle around. This is an extended center drill. A shorter one would probably have less of a tendency to want to jump. On an extremely critical part, if you're putting a center in and you know that that center has to be true, set your compound to 30 degrees, 60 degrees, whatever angle it is that you need. And if you can get in there and single point that, you'll guarantee that the concentricity is not affected by the setup. Just change over to a live center and dust that OD. The small shoulder diameter adjacent to the journal area is called out as 1/2 inch or 512.7 millimeters. If you are going to rough turn this down prior to going between centers, try not to go below that diameter if you intend to keep that feature on that part. In this area right here, this is a bigger diameter than this. I'm only roughing this now. Be careful about that diameter right there. Let's do it. I'm pleased with that. It's relatively clean, relatively concentric up here to the casting. That's a good thing. I want to take this to a diameter that fits in a collet, so I'll stay with a regular recognizable sign. You cut it to whatever size you can hold comfortably for the next stop. Currently positioned in a 31/64 5C collet. We're going to test the validity of the last setup. These should be running very concentric if you just took your time and made sure that both sides of this are the same diameter, just for this reason. All right, let's turn it on and look at that end right there. I'm going to stick the center back in here and get a little bit closer to the 374. I'm going to take it down around to the 400 mark. Leave myself about a 1/2 millimeter to clean that up between centers, because I know these things like to jump and chirp and bang and make all kinds of obnoxious sounds when you're trying to do it the way it should be done. So I'm going to cheat and get close before I ever have to worry about that. for sake of not bouncing your setup completely out of the between centers dog-driven arrangement that you're ultimately going to have to deal with, this would probably not be a bad time to establish the 500 diameters on the print and the width of this right here, because you know you got a good solid setup. You start doing an interruption in between centers and this thing is going to sing and chatter and just really let you know it's not happy. So consider it. It's definitely an option. Sitting on 423. Gonna go for 406. 406. 23 right now. We can consider the part roughed at this point, because this is what it looks like. It's starting to look more like the print. That's a good thing. This is where you get your calipers out, get your scales out, get your microscopes out, and start comparing what you have here to what is shown here. This is where you start needing to pay attention of what's coming off of what surface. So I'm going to do a mechanical inspection on this. I'm going to compare what we have or what I have, and I will know exactly what I can get away with back in the setup. I am going to do the interruptions, with the exception of the eccentric. I am going to do the interrupted surfaces in a collet, pinched right here on one side, naturally in the center on the other side, but that will greatly reduce the banging going on when it comes time for this to encounter this eccentric swing right here. Because boy, I tell you, between centers you can expect that to just make all kinds of noise. I might have said that 5 times already, but that's why. I'm going to double check it, see what I got. We'll put it back in the machine and clean them surfaces up. After a little bit of inspection, you're going to find out that that protrusion right there, those 2 arms that support the journal, are almost net shaped. There's about 5 thousandths that can be cleaned up off of each outer face. Now that is not the critical dimension. The critical dimension is the width of the entire unit to those 500 shoulders on each side. That's what's going to keep this thing centered in the frame and drive the casting accordingly. You also want that center journal centered about that 1" 250 thickness of the part here. And yeah, of all the collets I have, the one size that I sized down to, that particular collet is missing from the set, and I have no idea where it is. So, yep, I got to shim around the shank. Got to do what you got to do, right? All right, I'm going to clean up the outside edges of both sides of this thing, and I'm going to turn the 500 diameter on. I'm going to do it to print for now, but I really like that bronze bushing idea, and I may put shims in there after the fact. Let's do it. Once you've successfully cleaned up both sides of this protrusion, I'm sure there's a technical name for it, but I don't have it right now, so forgive me if anybody knows what they're called that hold that offset journal. By all means, let me know what it's called. There is a 45-degree call out on each of the outer edges. Here and over here. And just for sake of getting cleaned up, I ran a tool across the OD as well. Let's do the chamfer. Plan is to single point that 45 on there. I'm just getting too much chatter with the extension of the tools. The part is pulled out of the collet about another 100 thousandths to allow for the 1/2" shank tool that I'm using to clear the back side. Very consistent, no bounce in the tool, nice turn finish. Let's flip the part around, do that again. I'm going to remove the part, check those chamfers with a depth mic. If it needs to be recut, I'll mark it and recut it. Stay tuned. Back in the lathe for the final turning operations on the outside diameters of this part. After a couple of calculations, we are looking at approximately 130 out from each of the faces that's already been established. Now, I'm almost ashamed to admit that I did not have a dog small enough to drive this diameter. So, rig one up. Split cap on this side because that diameter is going to change operation to operation. First time it's going to be bigger, second time it's going to be smaller, and this is fixed. So the center to center is fixed, and this diameter, this cap is got 2 screws, so that comes down, it cinches down. This is just strictly going to be a back and forth, and we'll see if I can get some of it on video for you. But that's the center to center, and you just can't beat turning something straight if it's done between centers. Hopefully this has no influence on the part, because usually these float, but I trust the setup, and I'll see whether or not it works out that way. I've also got the mass of the crank opposite the mass of the clamp to try to balance the setup out. This is the configuration that I will be using for the final turning ops. I've taken it out of the hole and just allowed it to drive, spring loaded so it doesn't vibrate. I am going to go with the conventional bosses on the print to start, and I may turn them back, maybe not all the way to the outside of the casting itself, and maybe halfway, and just put a small washer on it, because I like that idea. Anytime you can keep metal on metal from happening, the better off you are. So there's no sense in showing the actual complete turning of this. I am about 10 thousandths away per side. I'll get it very close, and then I will polish it up, and we'll cut this center out here. I'm using a different camera for this, and I'm actually kind of, there you go, there it is. We'll saw this out and hope that there's no stress in this material, because if you saw a web out after doing such meticulous work to get everything straight and true and clean, and any stress in the work could cause it to pop, that would be most unfortunate. So we will pick this back up as soon as I get these sides turned to 374. 374 on the print, and that's what we'll shoot for. Side number 1 is complete, and I figured I would show you the technique used to get such a beautiful finish on cast iron, because turning a finish like that on cast iron can be challenging, if not impossible. So I'm actually going to do it the old-fashioned way, and a lot of you old-timers out there are going to go, "You go, boy." I'm going to do it with a file. Believe it or not, I will get that finish on there with a file. But you got to trust your file. That's the whole secret here. I'm going to use Yeah, this is about a 3/4 inch wide, extremely fine. And this is my, well, it might as well be a diamond lap because I just absolutely love this. I try not to do corners with this. It's only ever used for flat surface cutting. And the way you can tell you're cutting flat or not, I'm going to put a dark line across here. And when you bring the file down on top of it, you'll be able to see exactly what type of path your file is cutting. Is it cutting on either side or high in the center, or what it's doing? And if it takes a nice bite off the line initially, you know you've got a file you can trust, and you need to put that one on the side and just trust it forever. So I'm going to reposition a camera, maybe not this one, and I'm going to show you what we can do with a file. Okay, you start off with a line you can trust. And I think you can see it right there. Make sure the file is clean. Which it is. Here we go. Nice slice pass. You can see that the track that the file is leaving is relatively reliable. That was a very superficial pressure, and you can't tell when you initially do this whether or not it's the contour surface finish of the part or the file that you're going to use. So trust it for a couple minutes and see how it works for you. And that is a very consistent removal of that blue line. That is just beautiful. Surface finish is getting much better, much quicker. And dimensionally, we can give it a little bit more pressure. If you have one area of your part or another that you would like to address, put the line back on that. And work only in that area. Removing that line on this particular part is going to take off about 3/10. Still see some shadow of the line, which means the ink is down in the grooves of the part. So the surface finish could be better. I'm going to take it right to the number I'm shooting for. And I will finish with emery. I'm sitting on 374 right now, and I can expect that to go about a half a thou under by the time I'm done. This is very smooth. Let's do it. That finish is looking pretty good. If you are going to check dimensionally after the fact, make sure the part is cool. If you're not sure if it's red hot, get somebody else to test it. I'm only kidding. You can usually tell. All right. Go for some Scotch-Brite. Okay, right now I'm going to do everything in my power to bring the center to, or the edge to edge dimension in so that it fits within the frame. I believe the frame is called for 1 inch 253. I'm looking for a 1 inch 250 across these. I should have a couple coming off of each side. Two and a half off of each side. With a very sharp nose tool, I'm going to clean up the inside of that, and I'm going to run it down and create a small relief right there. Both sides. That's pretty. If you're doing this and you're wondering how far to come forward with this inside relief, this gives you a pretty good idea. I would say realistically, you don't have to come forward very far. There is plenty of room in there. Next phase of this operation is to create the eccentric lobe to drive the connecting rod. I am not going to beat this to death in an offset setup. I'm going to put this in the mill, I'm going to clamp it in the vise, and I'm going to clean this center section up, leaving minimal amount of material so that the interruption is minimized and the vibration will be minimized. So that'll be the first step. Then we're going to put it in the suggested fixture. Make it a little creative there. Stick around. All right, now for everybody that's already typing the comment, we're going to get back over to the bench and we're going to cut this piece out. We're going to relieve it out first with a hacksaw. I'm not even going to put it across the bandsaw. Then I'm going to rough this slot on the mill because interrupted cut. This side's going to want to sing and this side is rock solid. So that would be the next step. I like it. Getting close. I should rent these fixtures out. I'm just saying I should put them all in a box and send them. Great idea. Little behind the scenes warning here. Make sure that when you remove one of the webs in the crank that you remove the one that's in line with the journals that you've already turned. Don't make the mistake and remove the other one. Remove the one that is in line. However you have to. You'll see the benefit of having a turn surface here. It'll give me something to sit on that's parallel and give us a nice consistent web once we dial in center. Part is simply sitting on parallels in the vise with the saw cut side up. This is where you can customize this crank to your needs. If for any reason when you did your connecting rod, if it ended up too thin, well, then just accommodate this, make this thinner accordingly. The print gives you a 5/1000ths difference between the center of this opening right here, or the size of this opening, and the size of the connecting rod. So about 2.5 thousandths per side. I'm going to take an end mill, come right down through the center of it. Thusly, and that will give me a much easier target when I get into the lathe, go on the fixture. I'll be able to center up my tools a lot easier because one side will be inaccessible at that point. Front you could probably still get to, the back side you can't unless you take it out, and then you risk losing your concentricity. Okay, let's mill this out. Once you have clean surfaces on the inside that you can trust, here comes the math. Figure out what size the slot currently is. Measure both of these uprights. You want these to be the exact same thickness, so adjust the center of your cut accordingly to move left or right to balance these out, and then you'll know how much more to move the cutter to open up the center slot. But now's a good time to take a couple of measurements, figure out where the actual center is if you didn't pick it up with an edge finder. I did this by eye. I know the cutter is undersized. So give me a couple of minutes. I'm going to measure this up, find my center, and I'll be back. I'm going to have to beg your forgiveness here for a second. Sometimes I just skip over things that I take for granted and second nature. I want to explain how to pick up that center. I think it's important. If you've never done it, it could be a head scratcher. So let's just take a quick look at what's going on here. These are theoretical numbers. These do not represent what I just found on my part. But for sake of demonstration, I think it's important to show you. If you measured this thickness right here, and it came out to be 280, and you measured this thickness right here, and it came out to be 300, well, the difference in those two numbers is 0.20. Which one is smaller? This one is smaller. So we need material on this side so that it gets closer to being this size. Well, take this number, take the difference between these two numbers, which is 0.20 total, and split that in half. That is how much this center line needs to move in that direction. 0.10. Once you make your shift, dust each side again and watch for these numbers to deteriorate and increase, or deteriorate and increase, and get closer together. That's the way you're going to track your center. After you've done that and established on your digital readout or on your dial, when you have a dimension that's exactly the same on each side, that's when you go for the gap in the middle. And as the gap in the middle increases, these will decrease symmetrically and everything will be about center. Okay? I hope that's clear, and sorry I skipped over that. That's kind of important. Let's get back to the part. I'm going to go to my bag of tricks here and stick an expanding parallel in my part. Squeeze it. Now I have a positive surface I can run the mic on. Get a pretty good feel for where I'm at. And I'm looking at 432. Boy, I'm right there. I'm right there. Another light dust cut on either side. We'll go back to the lathe and finish that journal. Watch the gap on that side. You can see that the screw does give it some adjustment. Center to center this way is fixed. This is not going anywhere. 750 because it was hard set and re-indicated after the fact. If this journal looks off center this way to the body, these are the screws that you use to put it back on center, right there. Remember, it will be pinched in the chuck under a jaw, so in order to make any type of adjustment, you may have to unloosen the chuck to do so. There it is, how to work it in there. All right, let's go set it up. Here's a final look at the tool. There's a very good angle. You can see that the undercut I put in the center initially to reduce the thickness of the lands. I then went back in and created an angle on either one of those lands, leaving behind a very small straight section that you can barely see, but it's there. And then after that, I went in and I necked the tool back so that it wouldn't catch on the inside of the journals. Got a secondary tool relief on either side of this tool, so I don't have to worry about the lugs hitting the parting tool. It is cut back, only the very front is cutting, and I'm going to bring this slot to width. The diameter is complete, but the width is a little bit snug for my liking. It will probably work, but it's just a little tight and can't take the chance. Let's clean it up. That's a beautiful thing right there. I like it. Ready. Shine it up. fingers on this step, that's for sure. All I'm going to do is put some strip emery in there and take the ugly off, and we'll take it out and take a look. Here's the final product. Little blend on the inside. Still got the 500 diameters on the outside. I did not put any bushings on it. I may go back and do that. I don't know. We'll see. But this is what I want to see right here. Like a kid on Christmas, right? Coincidentally, it is Christmas. Let's put the rods on. Like butter. Love it. Crosshead. Drop everything in place. Well, you can't even feel it. Love it. Absolutely love it. Boy, that'll mess with the autofocus, won't it? Here I am. No, I'm over here. Oh. Just beautiful. I couldn't be happier. I'm going to clean it up. I'm going to go back over the print, see if there's anything on the print that needs to be addressed as far as tolerances are concerned. Some of these holes are called out as the same size as the rod, and being an OCD Virgo New Jersey toolmaker, I chose to hit the number right on the number. If it said 188, the hole was 188. So if there's a rod going through there that's 188, I will probably ream it out to 189, 190, depending. I could just sit and watch that all day. That's just too cool. All right, guys, it's another installment, and I will be back to put this thing together for you and take a lot of really super close-ups because I am thrilled the way that looks. Fantastic. Thanks for coming along. Do appreciate it. Joe Pye, Advanced Innovations in Austin, Texas. I'm out. Boy, if that doesn't make you smile, you're in the wrong trade. I love it.